Now let's talk about some basic vector math, and that is really the difference between 2 points, or the vector between 2 points. Of course, there are other vector maths out there that are usable in DEX, but this one, in my opinion, is the most important one. And the concept is as follows. When you have 2 points, and of course we work here in 2D because it's easier to understand, but it's the same in 3D, then let's say we have 2 points, point 1 at 1, 2, which is here, and point 2 at 5, 5, which is there. And of course, the numbers here define the vector from the center of the world. So this is very important because, as you can see, it also defines a direction towards that point or vice versa to the center of the point, which we actually saw in the fountain example. Now, to calculate the vector between those 2 points, all we have to do is we subtract one position from the other. And this might actually be something you know from school. It's pretty straightforward. The only thing that is interesting here is that the order that you subtract actually matters. So if you subtract the first point from the second point, you get this direction. But you could also invert that, and then you subtract the second point from the first point, and then you get the opposite direction. So you don't really have to remember, as you can see, necessarily the order. I always mix it up. Who cares? You just, try things out. But it's just interesting to remember that you can find both directions. So this is a basic idea. And actually, we already used that without being aware of it. And that is when we used our little trick in the fountain example, where we set the direction of the normal equal to the position, or I think we used velocity or whatever, but we used a position as a direction. And then this looks like this, that you have a direction that points away from the center, but it always is relative to the center. This is actually a short form of what we just saw, because what we did here is we took the end position and basically subtracted nothing from it. So this would look like this. We subtract a vector of 0, 0, 0, and as you can see, that results in the same thing. But this is coincidentally not just nothing, but this is actually the center of the world. So what we actually implied already is this kind of calculation of a vector based on 2 points, even though we just filled in 1 point. And to prove that to you, I can just change now the center, for example, to something like this. And as you can see now, the directions point 2 has changed because this was just implicit, and as soon as we put it in, we can actually change the directions point at to whatever we want. It also means we can use that to invert the whole thing by doing this. We just change the order of the 2, and then the direction has changed, as you can see. So it's not that complicated. It's just something you need to remember and do a couple of times. And actually, we already did. So this is basic vector math, how to calculate a direction between 2 points. And we will use that in a couple of examples later on. So I hope this is helpful. Thanks very much and see you later. Cheers.